Hello and welcome back to our third video. This is our walk cycle as we have made it with our wonderful simple wee, I don't know what he is, but whatever he is, he's walking along. Now what we're going to do in this short video is make him work in the game engine. Now making this guy work in the game engine is actually quite simple. I'm just going to go scale on X by say 3 and scale on Y by 3. Just give him somewhere to walk around in the game engine. The first thing we need to do is change to the game engine. We're in Blender Render, so Blender Game. So now we've got all of our game settings over here. Now the next thing we need to do is something probably you wouldn't expect. I'm going to add a cube. I'm going to scale that cube up. I'm going to look from the front here. I'm going to go SX and GZ and then SZ. And basically this cube is going to sort of envelop our character. And we're going to call this collision bounds 8. So we're going to use this cube as sort of a container, an invisible container, to put our player in. And hopefully that'll become apparent in a minute. Normally when you have a very complicated mesh, and this obviously isn't a very complicated mesh, but when you have a complicated mesh like a human hand or something, if you ask the game engine, any game engine, to compute collision detection on very complex shapes, some of which are concave and so you can go inside them, and it takes a lot of computing power, and you can slow down your game engine unnecessarily when, depending on the game, you could have something as simple as this. So collision based on a cube, the game can work out, or the computer can process very quickly. If we were doing something in the game that required very accurate collision, then we could think about doing this a different way. But for what we're doing today, this is a very efficient way of getting this character to move. So what I'm going to do is I'm going to take my skeleton and I'm going to go shift and right click on the box and go Control P, set parent to object, and that very simply makes the outside box now the parent. So wherever it moves, the what's inside will move. I'm going to make it invisible, so I've clicked on the physics tab. I'm going to press P in the game engine. Oh, I'm in wireframe mode, so P. There he is. Now he's not terribly well lit, he doesn't look very good, but that's okay. To get him so that you can now be in solid mode here and not see that cube, I can go to the cube's data, so the objects data here, and it says maximum draw type, and I can go to wireframe. And so no matter what settings I put anywhere else, this object, the highest complexity of visuals it can attain in the viewport is a wireframe. So that's a handy little tool to have. So I'm going to go G, Z, and just, there we go, move him just up above the floor level. Now over here, I'm going to make this guy dynamic. I'm going to give him collision box as or collision bounds as a box, and now very simply I'm just going to give him some movement. So we'll change this to the logic editor, and I'm going to say keyboard input. Let's use the arrow keys. We'll go up, so we'll call this forward, and we're going to apply motion. I'm going to apply it negatively on Y because that's the direction he's facing. So I'll say -0.1, and we'll call this forward as well, and connect those two. Now if I press P, oh, there's an interesting, so P, and he flies away. Now why does he do that? And it's interesting why he does that. He does that for a very good reason. If I take two dynamic objects and I put them inside each other, how do they sort of follow the sort of the rules of physics that say that they have collision, etc. So inside a dynamic object, we shouldn't have another object that is also, that has collision. So this here is a static object. Static objects like a building has collision, like the ground is static. So we need to tell it that this has no collision, and we also need to select our armature, but the armature by default has no collision. So now when I press P, he doesn't fly away, he just stands still. Now if I press the up arrow, he slides across. Perfect. Now, the other thing we did, if you remember from our controls, was we said mouse input, and it was mouse input movement. So we're going to call this turn. And over here, we said we would use mouse, and not visibility, we'd use look. And then we had to lock it on an axis. So let's see which axis we have to lock it on. So P, and that doesn't work. So let's turn off the y-axis. So P, and that's perfect. So I can move forward. Now, the last thing I need to do is I want to play my animation. How do I do that? Well, the animation is not on this box here, so I can't simply say add an action, play the animation, but that won't work. Why won't that work? Well, because this box has no animation on it. The animation is on the skeleton. So I'm going to say, when I receive a message saying walk, what should I do? Well, I should play my animation, which starts at frame 1 and ends at frame 50. And there's different ways to play something. So play just plays it from beginning to end. I can have loop stop is an interesting one. So basically when I stop sending the message, it will stop the animation mid-frame. So if my foot was still in the air, that's how it'll stop. So I'll call this walk. And yeah, we'll just leave that as message. And now here, when I press the keyboard, I'm going to send a message. And what's the message? The message is going to be sent to the ape rig, and it's going to be walk. So now let's go to solid mode, P. It's not working. So let's find out why it's not working. And maybe you've already spotted it already. I haven't. So I've pressed the up arrow. I am moving forward, and I'm sending my message, and I'm receiving my message, and oh, I need to turn on is true, I think. Frame 1, frame 50. Okay, so P forward. Well, let's just, this is interesting that it's not working, so let's bug test it. So let's just check that the animation works before we start working out if the message is broken. So what we can also do here is just replicate the input. So up arrow and connect that. So let's go P, and there's my walk. Okay, so there's something wrong with the message, my sending the message. There's nothing wrong with the actual walk. Now, I'm moving forward faster than, so I'm sort of sliding along. So what I should do on this one is I should reduce this, instead of being minus 0.1, it should be minus 0.05, say. So I'll move a little more slowly, but that will, reflect the animation a little better. That's me moving around in the game engine. Okay, now let me check my. Actually, I will just leave it for now, because what we're interested in is getting them to walk. So we'll worry about the message another day, and we'll just leave it like that, so that it's got duplicate input. So this is walk. So the same input for both, because that'll work just perfectly fine. Okay, so that is how how to get it to work, the game engine to work. So I'm just going to go File, Save As, and In-Game. So this is called Robot Rigged and Animated In-Game. Okay, and so that's it working in the game engine. Not very pretty, but definitely you know, quite an achievement to make a full 3D character, rig the 3D character, and then apply physics and logic bricks to get it to be completely interactive in a live game environment.